Hello, this is the final video of 5.2. The first thing I want you to look at are these properties of rational exponents. If you're taking the nth root of x to the n, and n is odd, then you'll get the sign, either positive 5 or if it were negative 5, you get the negative 5. But if n is even, you're going to take the absolute value of the number under the radical. So whether you're taking the fourth root of positive 3 to the fourth or the fourth root of negative 3 to the fourth, you will always get 3. So you'll get the absolute value. Keep that in mind. Now let's move to example 6 of your notes packets. We want to simplify the expressions. What I like to do is, if you don't recognize anything being perfect cubes, you can always go down to your factor trees. So 64 will break down to 8 times 8, and that'll be 4 times 2. So you can factor 64 all the way down. You can even write out y to the 6, which is basically 6 y's in a row. Now let's draw a blank radical, and we're looking for groups of 3 because we're taking the cube root. So you can see here we have a group of 2. It'll come outside the house. Another grouping of 2 will come outside the house. And then we have a grouping of y and another grouping of y. There's nothing left over, so we actually don't need the radical, and then you can multiply the things that came outside of the radical. So my final answer will be 4y squared. Now let's try it with a fraction or a quotient. What you can do is first break this up. So you can break it up into a fourth root of the top and the fourth root of the bottom. Now look at the numerator. X to the fourth is really like having 4 x's underneath of here. And on the bottom we'll have 8 y's. So every time you have a group of 4, it comes out of the house. So I'll have one group of x that comes out. Here I have one group of y and a second group of y. So 2 y's will come out, or y squared. Now let's move to example 7. For example 7, it's going to be very similar to example 6, except we might have some leftovers inside the house. So 4 can be broken down to 2 and 2. A will basically be like 8 8s. I'm not going to write them all out at this point. B, there's 14 of them. And C, there's 5 of them. So we're going to draw our blank house. Every time, and we're looking for groups of 5. We don't have 5 2s, so I'm going to actually multiply them back together and keep the 4 underneath. As far as the A's goes, imagine 8 across. We're going to have one group of 8, 5 8s, A's, sorry, and then there'll be 3 left over. So the 3 left over stay in the house because we need groups of 5. So imagine 14 B's. How many groups of 5 will you have? You'll have 2 groups of 5, that would be 10, with 4 left over. C's, we have one group of 5 with none left over. And this would be your final answer. Now looking at example B, we're not allowed to have radicals and denominators. And we need, since it's a cubic, so because it's a cubic or a cube root, we want a multiple of 3 in the denominator so that it can come out evenly. So right now we only have 8 y's. We would actually need 9. So we're going to multiply the top and bottom by one more y, cube root of y, so that we'll have 9 in the denominator. So the new numerator will be x cube root of y, and in the denominator we're going to have the cube root of y to the 9th. So the numerator is not going to simplify, but in the denominator 3 goes into 9 3 times, so 3 y's will come out. Now let's look at C. Again, don't be afraid of this. What I want you to do is focus on one thing at a time. So sometimes I just start with a blank fraction bar. Worry about the numbers first. 14 over 2, or 14 divided by 2 is 7. Now let's worry about the x's. I have x to the first on top and x to the 3/4 on the bottom. So you're going to want to subtract their exponents. So 1 minus 3/4. Or 1 whole pi, take away 3/4, leaves us with 1/4 pi. Now look at the y's. Notice I'm going in alphabetical order. Y, I only have the one y and it's a 1/3 up at the top, so that's it. And then z's, I have z to the negative 6 on the denominator. If you just move it up to the numerator, the exponent will then become positive. And actually everything's in the numerator, so I don't even need my denominator. And your answer would be that. Now let's move to example 8, adding and subtracting variable expressions. First thing you have to make sure is that the radicals are identical. They're both square roots of y. If that's the case, then you can actually add 5 plus 6 and get a total of 11 radical y's. Now that one was nice and easy, but notice in letter B, these are not alike. But see if we can simplify them first. In the first part, we have 5z's sitting underneath this cube root. So we can actually, so if I have 5z's sitting out here, I can take one group out. So I'll actually have 12z outside the radical, and underneath I'll still have my 2 and these 2 leftover z's. Now let's look at the next radical. 54 is pretty big. You can factor tree that down. 2 times 27, 3 and 9, and this will be 3 and 3. So I have a trio of 3's that can come out. So 3 comes out, and I have my cube root. What's left over? This 2 underneath is left over, and the z squared is left over underneath. So now these two are the same, and I can subtract 12z minus 3z and get a total of 9z cube roots of 2z squared. The next thing I'd like you to look at are the monitoring progress. You can look at 13 through 16, otherwise we will complete them in class.